What's up, everyone? Welcome back. It's a new week, so let's see what we're going to do. Today, we're going to do the following problem, which is actually equivalent to material from pre-calculus course, or for some people, you might actually have seen it in maybe algebra course. So it is similar to what we have done last week, which was to solve the inequalities of polynomials, but this time we're going to push it a little bit further. We're going to solve inequalities of rational functions. So before we jump into the problem itself, let's talk about what is rational function. A rational function is a function that looks like a fraction, or like something over something, where both the top part, the numerator, and the denominator are just polynomials. Good. So before we move on and talk about how to do this problem, you can pause the video for yourself to think about how to do it. And also, if you didn't subscribe to my channel, don't forget to subscribe. And you can also try to find my other videos from my channel. And you can also turn on the notification bell so that whenever I have new videos, you won't miss it either. Okay, so let's jump into the problem. So in this problem, we have the inequality x plus 1 times x plus 3 all over x minus 1 times x minus 3, which is greater than or equal to x squared plus 1 all over x minus 2 quantity squared. So if you have already taken or are going to take the pre-calculus course or something equivalent, in class, teacher will always tell you to just multiply all the common denominators to both sides and then to solve it. So what we're going to do, if we follow that instruction, we are going to find the common denominator. In other words, find the least common multiplier of the denominator part, which is in the green boxes. So what do we have here? We have x minus 1 times x minus 3. On the other side, we have x minus 2 squared. But since their common denominator is just, their common factor is just 1, meaning that in order to find the lowest common multiplier, or in here we call it the common denominator for some pre-algebra class, we need to multiply these two terms together so that we will get x minus 1 times x minus 3 times x minus 2 quantity squared. So that if we have this term here multiplying to both sides of the inequality, we see that the denominator on the left hand side will be cancelled out, and of course we have an extra term. At the same time, the rational function will also have the denominator cancelled out, and of course we still need to multiply with some other terms, so that once we multiply with this common multiple, we will be able to get rid of the function below and make it into polynomial. So if we do that, what are we going to get? We're now going to get x plus 1 times x plus 3 times, now x minus 1 is going to cancel out. X minus 3 is also going to cancel out. So what do we have remaining? We will have x minus 2 quantity squares remaining. Like this. Good. So now we're going to look at the right hand side of the inequality. Of course, we still have the numerator part, x squared plus 1. Then we see that the x minus 2 quantity squared will be cancelled out with here. so that we have x minus 1 times x minus 3 remaining. Meaning we are now going to have this. But here is a problem. In the class, when teacher tells us to do it this way, we are also warned that we cannot get greater than or equal sign anymore. In other words, we don't know how the inequality is going to change. So in fact, we cannot use greater than or equal here. We now need to assume the following. So we're going to assume, or you can say let, instead of having an inequality, we will let this be an equation. So again, for the trick that we have learned, or the method that we have learned in class, the teachers will always tell us that solving this needs two things. Number one, we need to find the common multiples of the denominators. Number two, we need to change the inequality sign, no matter if it is greater than or equal to, or if it is less than or equal to, or even if it is less than. We always need to change it to equal sign before we continue the calculation. And in fact, if we do this, now we're again trying to solve the equation of polynomial, so that we're going to solve again, this is what we call the root of the polynomial. But is it necessary to do that? Of course, if we use this method, we have to do it this way. And again, the reason is we cannot tell whether we're multiplying by a positive number or a negative number or even zero. So if we can guarantee that it's a positive number, great, we know that the sign doesn't change. If we know that it always is a negative number, good, we know that we must flip the sign. If we know that it's zero, which is actually not possible. Again, these are actually part of the denominator. So we cannot assume that any of the factors is zero, because if any of the factors is zero, we now have something over zero on one side of the inequality that we start off. So don't worry about the case that we're multiplying both sides by zero. But the problem is we cannot always guarantee that that is a positive value or a negative value. And that's why we can not always guarantee that we can keep the sign or has to flip the sign. Okay? So that's why we always need to write as an equation if we use this method. But today, I'm going to introduce a method or a trick that we don't have to worry about changing it into an equation. We can still do it as an inequality. How do we do it? Here we go. So we're still trying to find the common multiple of all the denominators, which are given right here. However, again, we cannot now guarantee that this term is always positive or always negative. And the reason is, again, we could actually have sometimes some part is positive, but some other parts will be negative. How can we make it always positive or always negative? Here is the deal. Whenever we see the factor that has no exponent, or in other words, the exponent is 1, right? If we see the exponent is actually an odd number, we're going to add one more copy to it. So in other words, right now, for x minus 1 term, there's only one copy of this factor. And 1 is an odd number, so we need to get one more copy, meaning we're going to have 2 copies in total. So we'll raise it to the second power. Similarly, x minus 3 has an exponent 1. So we need to raise the exponents into one more, which is 2. Good. Now, for the last term, we have the exponent that is even. In fact, it is 2. Then we don't have to change it at all. So keep in mind, if the exponent is odd, add 1. If the exponent is even, leave it or keep it the same. Why do we do that? Because we now know that each factor on the bottom must be a real number. And also, since those factors are in the is in the denominator on the bottom, we have to assume that those factors cannot be 0. Otherwise, we will solve with something divided by 0. Okay? So, we already know that x cannot be equal to 1, 3, or 2 in this case. So, we don't have to worry about what happened when some of the factors is 0. So, we know that those factors are either positive or negative. In other words, it must be a real number. Then what happens if we square that term? Well, if it is positive, we square it, it is still positive. If it is negative, we square it, it becomes positive. So what does that mean? It means that if we square it or make it into an even power, we now can guarantee that as long as x is not equal to the number after, the term x minus whatever has to be positive if we raise it to an even power. Good. So why is it powerful? Because now, if each term here or each factor is positive, we have the product of it, which is also positive. So that guarantees us that if we multiply both sides by this whole product, we're multiplying with a positive value. In other words, if we're multiplying something by positive in an inequality, we do not need to flip the sign. The sign remains the same. So let's see what's going to happen. If we multiply the left-hand side by this part right here, we now get the numerator x plus 1 times x plus 3, of course, times, now we need to look at the denominator part. We see that there is an x minus 1 in the denominator, but we have only one copy. So if we multiply with this big term on the right, one copy has cancelled out, and we have one copy remaining. Like this. The 2 becomes 1. Similarly, we have one copy of x minus 3. So multiply with that, we have x minus 3 raise it to 2 minus 1 power. One copy cancelled out. So we have x minus 3 to the first power. And last but not least, we still have the x minus 2 squared. That is not going to cancel with anything on the left-hand side. Great. So again, since we're multiplying with a positive value, we guarantee that the sign is not going to flip. Then we can just move on to the right-hand side. So for the right-hand side, we have x squared plus 1, which is a numerator, times, again, we have x squared, x minus 2 squared, cancel out with x minus 2 squared here. And we now have x minus 1 squared times x minus 3 squared to the right-hand side. Okay. X minus 1 squared, x. And then after this, we just have another polynomial to solve. Inequality of polynomials. So at this point, keep in mind that when we want to solve for equation or inequalities, the best for us to do is factoring. If we can factorize something out, that would be the best, because if we factor out something, we'll be able to solve the equation easier. or the inequality easier. So instead of multiplying everything in, let's see if we can just put something together or try to find common factors and then solve the equation. So first thing, of course, we gotta move the right hand side to the left by subtracting it. So we now get the left hand side minus the right hand side is greater than or equal to 0. Then we're going to factor out something that are in common, such as we have x minus 1 and x minus 1. We have one copy of x minus 1 on the first term, and then we have two copies. So how many copies can we factor out? 2, right? No, we can only factor out 1, because we can only take the minimum of all the terms. Since there's only one copy here, we can take out one copy, so that there's no more copy anymore. But here, we can take out one copy, and then we still have one more copy left. Good. So what else can we factor out? X minus 3. Very good. Such that now we just need to put everything else together. For the first term, we factor out x minus 1 and x minus 3. We have x plus 1 times x plus 3 times x minus 2 quantity squared minus the second term. What do we factor out? One copy of this and one copy of that. So we have one copy left for each factor, meaning we have x squared plus 1 times x minus 1 times x minus 3, which is greater than or equal to 0. Then of course, since there's nothing more we can factor out right now inside the brackets, we now need to simplify it by multiplying and then try to cancel or combine the like terms. And if we do that, we will actually end up with 4x cubed minus 13x squared plus 8x plus 9. And then don't forget, we need to write it down the right hand side, greater than or equal to 0. Good. So up to here, what should we do? Well, just like the video from last week, we know that when we have an inequality of polynomial like this, we can just use some of the methods that we have learned. We can try to we have to first find out the solutions of this polynomial here. The good part is we know how to find the solution for this part. We also know how to find the solution from this part. But do we know how to find this? No. At this moment, we don't know how to find this yet, because this is a degree 3 polynomial, or known as a cubic polynomial. Do we have a cubic formula? We actually do. So, did we talk about it? Not in my channel. For tomorrow's video, you will see how we can actually derive the cubic formula, meaning the formula for any general cubic equation. And after that video, we will come back and figure out how to solve this part for this inequality here, so that we will be able to end our solution. Okay, that's it for this video. Thank you for watching. I will see you guys tomorrow.